Hello, myself B. Chanakya and I am from ECE 3A. Today I am going to explain addressing modes of 8051. In 8051, there are 1 byte, 2 byte instructions and very few 3 byte instructions are present. The opcodes are 8 bit long. As the opcodes are 8 bit data, there are 256 possibilities. Among 256, 255 opcodes are implemented. The clock frequency is 12 MHz, so 64 instruction types are executed in just 1 millisecond and rest are just 2 milliseconds. The multiplication and division operation takes 4 ms to execute. The addressing mode is a way to locate a target data which is also called as operand. The 8051 family of microcontrollers also allows 5 types of addressing modes for addressing the operands. They are 6 types of addressing modes. They are immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, index addressing mode, implied addressing mode. Immediate addressing mode. In this immediate addressing mode, the data is provided in the instruction itself. The data is provided immediately after the opcode. These are some examples. Immediate addressing mode. The immediate addressing mode, the operand which follows the opcode is a constant data of either 8 or 16 bits. The name immediate addressing came from the fact that the constant data to be stored in the memory immediately follows the opcode. The constant value to be stored is specified in the instruction itself rather than taking from a register. The destination register to which the constant data must be copied should be the same size as the operand mentioned in the instruction. Example, move a, hash 030h. Here the accumulator is loaded with 30 hexadecimal. The hash in the operand indicates that it is the data and the not address of a register. Immediate addressing is very fast as the data to be located is given in the instruction itself. In this addressing mode, the source operand is constant in immediate addressing mode. When the instruction is assembled, the operand comes immediately after the opcode. When R0 and R1 are used as a pointers, that is when they hold the address of a RAM location, they must be preceded by the @ sign. And register addressing mode. In this register addressing mode, the source or destination data should be present in a register R0 to R7. There are some examples of register addressing mode. Register addressing mode involves the use of registers to hold the data to be manipulated. In the 8051 microcontroller memory organization tutorial, we have seen the organization. In the 8051 microcontroller memory organization tutorial, we have seen the organization of RAM and 4 banks of working registers with 8 registers in each bank. In register addressing mode, one of the 8 registers R0 to R7 is specified as operand in the instruction. It is important to select the appropriate bank with the help of PSW register. Let us see an example of registers addressing assuming that bank 0 is selected. Example, move space A, R5. Here the 8-bit content of the register R5 of bank 0. And next, direct addressing mode. In the direct addressing mode, the source or destination address is specified by using 8-bit data in the instruction. Only the internal data memory can be used in this mode. Here some of the examples of direct addressing mode. The direct addressing mode, the address of the data is specified as the operand in the instruction. Using direct addressing mode, we can access any register or on chip variable. This includes general purpose RAM, SFRs, input output ports, control registers. For example, move space A, 47H. Here the data in the RAM location 47H is moved to the accumulator. In direct addressing mode, the data in a RAM memory location whose address is known and this address is given as a part of the instruction. Contrast this with the immediate addressing modes in which this operand itself is provided with the instruction. Register indirect addressing mode. In this mode, the source or destination address is given in the register. By using register indirect addressing mode, the internal or external addresses can be accessed. The R0 and R1 are used for 8-bit addresses, and direct pointer is used for 16-bit addresses. No other registers can be used for addressing purposes. Let us see some examples of this mode. In this register indirect addressing modes, a register is used as a pointer to the data. If the data is inside the CPU, only register R0 and R1 are used for this purpose. In other words, R2 to R7 cannot be used to hold the address of an operand located in RAM when using this addressing mode. In this indirect addressing mode or register indirect addressing mode, the address of the operand is specified as the content of a register. This will be clear with an example. For example, move space A, @R1. The @ symbol indicates that the addressing mode is indirect. If the contents of R1 is 56H, for example, then the operand is in the internal RAM location 56H. If the contents of the RAM location 56H is 24H, then 24H is moved into accumulator. Only R0 and R1 are allowed in indirect addressing mode. These registers in the indirect addressing mode are called as pointer registers. Indexed addressing modes. In this indexed addressing modes, the source memory can only be accessed from program memory only. The destination operand is always the register A. These are some examples of indexed addressing mode. With indexed addressing mode, the effective address of the operand is the sum of a base registers and an offset register. The base register can be either data pointer or program counter, while the offset register is the accumulator. In indexed addressing modes, only move C and jump instructions can be used. Indexed addressing mode is useful when retrieving data from lookup tables. Example, move CA, @A plus direct pointer, that is DPTR. Here the address for the operand is the sum of contents of direct pointer and the accumulator. Indexed addressing modes is widely used in accessing data elements of lookup table entries located in the program ROM, that is ROM space of the 8051. The instruction used for this purpose is move A plus direct pointer. The 16-bit register direct pointer and the register A are used to form the data elements stored in on-chip ROM. Because the data elements are stored in the program space ROM of the 8051, it uses the instruction move C instead of move. And coming to implied addressing mode. In the implied addressing mode, there will be a single operand These types of instructions can work on specific registers only. These types of instructions are also known as register specific instructions. And here are some examples of implied addressing mode. And types of instructions in the 8051 microcontroller's instruction set. Before seeing the types of instructions, let us see the structure of the 8051 microcontroller instructions. An 8051 instruction consists of an opcode short of operation code followed by operand of size 0 byte, 1 byte or 2 bytes. The opcode part of the instruction contains a mnemonic which specifies the type of operation to be performed. All mnemonics or the opcode part of the instructions are of 1 byte size. Coming to the operand part of the instruction, it defines the data being processed by the instruction. That operand can be any of the following: no operand, data value, input output port, memory location, CPU registers. There are multiple operands, and the format of instruction is as follows. 8051 has simple instruction set in different groups. There are arithmetic instruction, logical instruction, data transfer instruction, branching and looping instructions, bit control instructions. And thank you.